Hi and welcome to E-ZTutoring. Today we're going to cover how to add and subtract logarithms as well as an additional logarithmic rule. So I suppose you may have seen something like log of A minus log of B, or something like log of A plus log of B. Well, whenever you're subtracting logarithms, there is one way you can combine them. Now, before you combine them, it is very, very important that these logarithms have the same base. Now, if you don't see a base on that logarithm, it means that the base is 10. And whenever the base is 10, you don't have to write it because a standard log is a log base 10. Anyways, going too much into detail here. So whenever you're subtracting logarithms, subtraction actually turns into division. So you combine these into one logarithm, and then you have to do something with the a and b, and that's where division comes into play. So then you take your first letter, which shows up, a, and you divide that by the second letter that shows up, b. So this is one of your rules. And on to the next one. Whenever you are adding logarithms, addition will turn into multiplication. So this becomes one logarithm of a times b. Now these rules also work backwards. If you see log of a times b, you can split it up into log of a plus log of b. So these are your two rules, which are very important. There is one additional rule which has to do with exponents. Suppose you have log of a to the power of b. Whenever you have a power on that letter inside the logarithm, you can actually take the power and bring it out front, so you have b times log of a. These three rules are very, very important. I will go ahead and actually leave these up as I'm working on the problems, just so you can have them for reference. So now we are going to actually solve some logarithmic equations here. Suppose we have log, well actually 7 times log base 3 of x minus log base 3 of 4 equals log base 3 of 16 plus 5 log base 3 of x. So whenever you have to solve something like this, first thing that I recommend doing is this rule. So let's go ahead and label these as rule number 3, 2, and 1. So rule number 3 should always be the first one you do. So where do we see that over here? Well, we see a 7 in front of the log here, and we see a 5 in front of the log here. So those are the two places where we can do it. And the reason I looked at those places is because over here there's a number in front of the log. So that applies to rule number 3. So we do this backwards now. So we bring this on top of the x. Now what I'm doing here is I'm compressing a logarithmic equation. It's called compressing and expanding logarithmic equations. So we put the 7 on top of the x, and over here do the same thing, log base 3 of x to the power of 5. And then these, we leave them as is. And also one more very important thing you should notice is that all of these logarithms have the same exact base, which is very, very important. So now we can start combining these. Whether you do rule number 2 or rule number 1 first does not matter. So let's go ahead and combine these. So this is subtraction, which means that we will end up using division. So we combine these into one logarithm, and we get x to the 7 over 4, and this is base 3. Then we do the same thing over here. Now this time it's addition. So addition means we multiply them. So we get log base 3 of 16x to the 5th. Okay, so now we have one logarithm is equal to another logarithm, same base. So therefore, since everything here is equal, therefore these must be equal to each other. I guess you can kind of call this another rule, that whenever a log with the same base is equal to a log with the same base, whatever's inside them must be equal to each other. It only makes sense. So we have to make more room on the board. We'll bring this up here. X to the 7th over 4 equals 16x to the 5th. So let me go ahead and erase this. Okay, so now this becomes simple algebra in order to solve this for x. So we can start by getting rid of the 4 and simplifying the numbers around. So if we're dividing by 4 and we want to get rid of 4, we simply multiply by 4 and they cross out. So we multiply by 4 on both sides, and this gives us x to the 7th equals, what does this give us? 64 x to the 5th. So now we got rid of the numbers. Now we want to get rid of the x's, so we have just one x that shows up in this equation. Well, we have x to the 5th and x to the 7th. We want to get rid of the smaller one, so we divide by x to the 5th on both sides, and we end up getting here x squared, because 7 minus 5 is 2, equals 64. So now if we want to solve for x and we have x squared, we simply take the square root on both sides, and we end up getting that x is equal to plus or minus 8. So whether it's the positive 8 or the negative 8, it's usually both, but I do recommend plugging this into your logarithm and testing it. Either way, that is how you solve that problem. Let's go ahead and go on to the next problem. Okay, so now suppose we have 3 log base 2 of x plus log base 2 of y minus 2 log 2 of z. So once again, you have to realize that all these logarithms have the same base, which is very important, which means we can combine them. So in order to start combining them, like I said, you must do rule number 3 first. So that means take the numbers in front of the logs and put them as exponents. So we put the 3 up here, we get log base 2 of x cubed. And we do the same thing with the 2 here. So we have minus log base 2, put the 2 up here, and we get z squared. So now we just have to do a mix of rule number 1 and 2. So we have addition over here, which means we will multiply x cubed and y. So we have log base 2 of x cubed times y minus log base 2 of z squared. So our last rule that we have to do is the subtraction rule, which means we divide the numbers. So we combine these to get log base 2 of this divided by this. So we have x cubed y divided by z squared. And this would be your final answer. So that is how you add and subtract and combine logarithms. In my next video, I will cover how to expand logarithms. Now, for additional ACT or SAT help, be sure to visit my website, www.E-ZTutoring.com. Thank you guys, and good luck.